Graph, object dropped from rest. Welcome. An object is dropped from rest. Graph vertical displacement on the y-axis versus time on the x-axis. Ignore air resistance. Assume constant acceleration due to gravity g. Positive x is defined as to the right. Negative y is defined as vertically down. Where do we start? We start with the equation for vertical displacement, and that is equal to v0t plus 1/2 at squared. What is delta y? Vertical displacement in meters, and that is equal to y final minus y initial. So again, what is delta y? Delta y is y final minus y initial. Let's try to understand delta y. If we define our 0 at this level, then anytime you go below the starting point, our delta y is negative. Because this becomes y final and this becomes y initial. And what is y final minus y initial? So what is y final minus y initial? Some negative number minus 0, and that is a negative number. What is our v0? Initial velocity at the start at t is equal to 0 seconds. It is dropped from rest, so it is equal to 0. What is t? T is the time in seconds. And what is a? It is the acceleration along the vertical. Very close to the surface of the earth, acceleration is, the vertical acceleration is the acceleration due to gravity. And that is negative 9.8 meters per second, provided positive y is defined as vertically up. So we have delta y is equal to v0t plus 1/2 at squared. Into that equation, we apply something that we know. What is it that we know? We know that it was let go from rest. It was dropped from rest. What does that mean? It means that the initial velocity is 0. If the initial velocity v0 is 0, that first term will go to 0. And then what are we left with? Just 1/2 at squared. Now what do we do? So we have delta y equals 1/2 at squared. So delta y is equal to 1/2 at squared. And into that, we substitute a is equal to negative 9.8 meters per second. So we substitute for a, and when we substitute for a, 1/2 negative 9.8 t squared. So this is nothing but equal to a. And what is 1/2 of negative 9.8? Negative 4.9. And then we still have t to the power of 2. So you have negative 4.9 t squared. So our delta y, our displacement along the vertical is negative 4.9 t squared. What is t? T is the time in seconds. So all you have to do is substitute t is equal to 1 and get the displacement for t is equal to 1. So t is equal to 1, what do we have? Delta y is equal to negative 4.9. Why? Because t to the power of 2 is 1 to the power of 2, and that is 1. So what is 1 times negative 4.9? Negative 4.9. How about t is equal to 2? What is delta y? It will be negative 4.9 times 2 to the power of 2. T squared, right? So negative 4.9 times 4. How about t is equal to 3? What is delta y when t is equal to 3 seconds? Negative 4.9 times 3 squared. So that's what we did here. Time is 1 second. And when time is 1 second, substitute into negative 4.9 t squared. And when t is equal to 1, we get negative 4.9. How about when t is equal to 2 seconds? When t is equal to 2 seconds, you substitute t is equal to 2, and what do we get? Negative 19.6, so many meters. so many meters. And when t is equal to 3, what is t squared? 9. And what is 9 times negative 4.9? Negative 44.1 meters. So you put time on the x, vertical displacement on the y, and when t is equal to 0 seconds, what do we get? 0. So that's right here. When t is equal to 1 second, what happens to delta y? It is negative 4.9. So where are we? We are 4.9 meters below the 0 level. What happens when t is equal to 2? When t is equal to 2, what happens when t is equal to 2? We are 19.6 meters below the starting point. How about when t is equal to 3 seconds? When t is equal to 3 seconds, we get 44.1 meters. We are below the starting point. 44.1 meters below the starting point, and that's the reason why we have a negative. So this is 44.1 meters. So t is equal to 1 second, we are 4.9 meters below the starting point. And how do we say that? Negative 4.9 meters. When t is equal to 2 seconds, where are we? We are 19.6 meters below the starting point. How do we say that? Negative 19.6 meters. When t is equal to 3 seconds, we are 44.1 meters below. How do we say that? Negative 44.1 meters. So we have time, we have the displacement, and when we plot that, this is what we get. So 4.9 below when t is equal to 1 second. So t is equal to 1 second, we are 4.9 meters below. When t is equal to 2 seconds, we are 19.6 meters below. When t is equal to 3 seconds, we are 44.1 meters below. So this is our graph. And this is George Mathew signing off. Good luck.